reducing air leakage. So that effectively that's kind of conserving energy by reducing heat losses. Once you're there, it becomes much more let's say cost effective and easy to start implementing upgrades on your heating system, and equally to look at indoor air quality at the same time, and to provide ventilation. And then eventually, once you are as efficient as possible, then it makes a lot of sense to move to renewable energy supply for heat and for power. So that's a kind of a three-step approach, if you want. So again, today we're starting with the first most important bit, which is to conserve heat. And so in today's presentation, we're going to look at how to insulate the different types of roofs, and roofs are a key aspect of it all. They represent about a quarter of our overall heat losses in a typical home. We are then going to look at the walls, which are equally important, where about a third of heat is lost through the walls, and that is in a typical situation. Then, in order of priority in terms of impact, windows and doors can have a real impact as well, because they represent maybe 18%. In a typical situation again, and air tightness and draft proofing the home, it can be also very cost effective and not only reduce heat losses but really improve the comfort. Floors, is something that is less important in that your floor is typically not in contact with the cold outside air. It's in contact with the ground, which is a more stable temperature, and therefore heat losses will be lower there. So typically in the ranking order of priority, it would be lower. But we'll come back to all these different elements of home insulation and discuss them in a little bit more detail in a moment. And I should mention also thermal bridging, which is, let's say, cold spots around the house at key junctions where heat loss is intensified. And it's not just a question of losing heat, but it can be a problem from the point of view of mold growth, etc. So before we start looking at let's say, those different elements of the fabric of your building, let's talk about the different types of insulation materials available. There are kind of three broad categories. First of all, we've got mineral fibers, which are typically relatively loose and low density and come in rolls, in bales, and they're quite, the most common type of insulation we're all quite familiar with. Glass wool, that kind of yellow fluffy insulation you'd find in most attics. Rock wool is a different version. Both are made essentially from sand. Glass wool would have a lot of recycled glass actually built in, and rock wool is made of basalt as a key component. Then we're talking about oil-based foam insulation materials. So these would be made from, let's say, essentially petroleum, and there are different types of chemicals used. Commonly, you've got polyurethane, isocyanate, I think. You've got expanded polystyrene, and maybe another 2 or 3 of that type of foam insulation material. They are generally rigid boards, and their performance is higher than the more fluffy, loose, low density material in mineral fiber insulation materials, but they're also generally more expensive, more effective, but more expensive as well. And then you've got natural fiber materials, including wood fiber, hemp fiber, ship wool, and cellulose, which is a recycled newspaper, effectively, which is treated with borax in terms of fire safety, and is typically blown in an attic space. There are kind of different characteristics to consider. So there's actually a bit of background noise going on. So can you make sure that your mic is turned off for the time being, and before we move to the Q&A section. So again, different characteristics to consider. Costs, obviously. As I said, the oil-based foam insulation materials are more efficient, but they're more expensive as well. While mineral fiber insulation is, one of the cheapest form of insulation, but because the density is low, you need to, or let's say the insulation per thickness is quite low. You need, a good layer of insulation to achieve the same amount of insulation performance, let's say. And so it's always a balance between cost and performance, and it's horses for courses really. And you'll see in a moment that there are certain cases where, for example, foam insulation boards are most effective. The other aspect of it is suitability. So, for example, you can't use mineral wool insulation under concrete slab. It would be totally squashed. That's not what it's made for. Or in some cases, let's say more natural fiber material are very useful on walls, for example, but they need to be treated specifically against water ingress, etc. So, it's, again, they need to be specified for the right type of job. And it's also about the green credentials. So there is increasing evidence and awareness that the insulation materials do require energy for their manufacturing, and they have what we call the embodied energy, and with that a carbon content. So we need to balance the level of insulation that's achieved and the reduction in heat loss but also take into account the fact that these contain energy or carbon that needs to be offset. And typically, the balance is positive in that you recover the energy that's built in the material through energy conservation over a period of maybe 2-3 years in typical situations. But let's say from the point of view of environmental impact, we would favor natural fiber materials, and wherever possible and budget allowing, they can be a really good option. So then let's look at the different building elements, and start with the roofs, and within that, pitch roofs that would have, where insulation would go at the ceiling level, on a flat ceiling. So, many homes in Ireland would have a cold attic, effectively, where the insulation has been rolled, if any, has been rolled between the rafters. And good practice there is to achieve an overall insulation layer of maybe at least 300 mil, and we often recommend, wherever possible, to bring the level of insulation to 400 mil. In many cases, it can be DIY jobs. So you can go to the hardware store and install that insulation yourself. Obviously, you need to be careful, health and safety first. And push on a mask, and the fibers of mineral wool insulation can be irritant as well. So there's a few precautions to take. But what's important to consider is the fact that when you're increasing the insulation at ceiling level, you're preventing any heat to migrate into the cold attic, and any vapor that goes through the ceiling and through the insulation into the attic, which is then very cold, can condensate and create situations of, let's say, water accumulation, which not only reduces the effectiveness of the insulation, but also can cause rot and mold within the attic space. So it's very important to ventilate the attic properly, and to make sure that air can flow relatively easily along the let's say the eaves of the house. or and that can be again achieved by making sure that you're not blocking that space between the rafters, as you can see in the picture on the left side, so that air can flow from the eaves through the attic and out again. Or you can install vents, they call slate vents or vent slates. I'm not too sure, but you know what I mean. These are kind of slates with a vent built in, and that would allow air to circulate within the attic. Another thing to consider is, are you using your attic as a storage space? So if that's the case, you have a number of options to make sure you've got, the space underneath that hard surface is insulated, but that you can, you can load that surface sufficiently to be storing, let's say, your Christmas decorations and that kind of stuff. So what we normally do is to push a rigid board across the rafters and push some, let's say, floorboards on top of that. So simple OSB board would do the job perfectly well. A few other things to then consider is, from a health and safety point of view, is where there are electrical cables that are, laid over the existing roof ceiling surface, typically quite loosely, and typically it's quite a mess. So certainly identifying those cables that are heavy duty, those cables that be connected to an immersion heater or to an oven, for example, can overheat if they're pushed under the insulation. So they need to be lifted, maybe hung onto the joists in the attic, and then the insulation needs to go underneath to make sure that they're not, there's no risk of fire there. The same would apply to dawn lighters. What would have typically happened is the insulation is laid around those dawn lighters, but that leaves a significant space of attic, of ceiling not insulated, and a big gap where you can have a lot of air movement. From an air tightness point of view, if there are dawn lighters in your house, I can guarantee you these are an important source of heat loss. So what we would recommend is to push over those dawn lighters either a big flower pot or a fire graded cover, and these are proprietary covers that will ensure there's enough air around the dawn lighter that also blocks let's say the airflow that would normally happen there around the dawn lighter. And then you can overlay the insulation over the dawn lighter without risk of overheating and potentially fire. Finally, it's worth mentioning cold water tanks in the attic, if there are some, and they need to be, you need to prevent frost from happening there. So it's always useful to leave, maybe put a minimal amount of insulation below the tank, but then wrap the tank itself so that it's protected from the frost, the very cold conditions that might happen in the attic. So I think that covers all the different aspects of, let's say, typical attic insulation. Then we have the cases where the ceiling is sloped. So we've seen that in many dormer bungalows, obviously, or older farmhouse, where some sections of the ceiling can be on a slope, and that's much more difficult to insulate than let's say, flat ceiling. Let's say, if you're replacing the roof cover, then it's an ideal time to go and place insulation from above the ceiling itself, and as part of the, let's say, re-roofing process. Otherwise, the only option really is to insulate from the inside. And In some cases, you can insulate between the rafters and then add a layer of insulation, like the picture on the left here is a good example. So you insulate between the rafters, you add a layer of insulation across the rafters, and then you finish that with a plasterboard. Typically that's skimmed and to provide you a good finish. If if you are, let's say if there is already, for example, a layer of insulation between the rafters, it might typically be, maybe 10 centimeters of mineral wool. That might be good enough, and applying a layer of insulation inside, so an insulated plasterboard effectively, is a relatively practical way of doing it. Obviously, all these internal insulation measures are quite disruptive, and can be quite expensive as well. So, but that might be the only option you have to insulate those sections of your roof. What's important though is to maintain a good level of ventilation on the cold side of the roof and the rafters, so that to make sure that there's a gap between the new insulation layer and the roof cover itself, so that again air can flow between the rafters, from these between the rafters and out at the apex of the roof, or out the other side of the roof, so that again any moisture that penetrates through the insulation can be ventilated out and doesn't condensate within the roof fabric itself. Flat roofs, similar principle really as the previous slide, whereby we can insulate from the inside, and typically a flat roof is what we call the cold roof. So you might have some insulation between the rafters. Are they rafters or joists? I'm always a little bit confused. We'll call them rafters, right? But those horizontal timbers. So you can insulate between those rafters, but you need to make sure that there's again a gap between the roof cover and the insulation, so that that gap can be ventilated. In fact, in many cases, there isn't a gap, there isn't ventilation. So these situations need to be looked at carefully, and the risk of condensation considered. Ideally, you want to do the insulation from the outside, so above the existing roof cover. So you're kind of re-roofing, you push a layer of insulation, typically a rigid board, and then finish that possibly with let's say a timber deck, and then a membrane that will do the waterproofing. And that's what we call the warm roof. That's ideal because you don't have a risk of condensation within the roof structure itself. And you can add a significant amount of insulation without impeding within the internal space. I should have mentioned here that because any insulation is going to take in the headspace essentially within the room underneath. The rigid boards with a high level of insulation per, let's say, an inch of insulation is very helpful in achieving a good level of performance without taking too much space internally. Cavity wall insulation. So until maybe the 30s, most walls would have been built as, let's say, solid brick or solid stones walls. But from that period on, cavity walls started to appear, and initially in brick walls, but eventually with the advent of concrete blocks, we've seen many houses built with a cavity in Ireland, with either two concrete blocks, one inside, one outside, or concrete block inside, and then a brick layer on the outside. And the function of that cavity is to allow for any kind of rain penetration or moisture penetration to drain down through the cavity. It's only really when, with the advent of building regulations around the late 80s, early 90s, that we're starting to see an insulation layer being placed within that cavity, typically, maybe an inch or an inch and a half of the white polystyrene. Which means that in most cases, actually, there is a gap within that cavity. Either there's no insulation and you can pump that cavity entirely, or there may be a layer, but there's still a gap of maybe a couple of inches that can be filled. So the measure there, which is called cavity wall insulation, is to drill a hole at key locations on the wall and then pump typically an insulation bead with a bonding agent in the cavity and under pressure, so that you fill all the gaps wherever possible. It's very good practice before that's being done to inspect the cavity. So you can use a little camera called a borescope, I think. So you drill a small hole, you push the camera in, and that camera will let you inspect what are the typical, what's the situation in there, is there a material ready, and to generally make a good plan for the cavity wall insulation. So it's a low-cost measure. Typically, it's not intrusive. It doesn't take in the internal space. It's very little disruption involved in doing it, and it's becoming quite a standard nowadays for older homes. And it's not uncommon to see homes with those little patches that you can still see if the after maybe one layer of paint or two, but that eventually will disappear. But they would be done extensively across the country. So then let's go a bit deeper and let's look at external wall insulation. So for those properties that don't have a cavity wall and can't have that kind of low-hanging fruit of insulation or wall insulation, should we say, external wall insulation is a good option. That might be for solid walls that were built, pre-1930s. Typically, these would have been either brick walls or stone walls again, or more recently, possibly until the 90s, homes could have been built using breeze blocks or hollow blocks, as they can be called as well. Which would have a very poor level of insulation, and those homes would have been quite cold. So these type of walls would be ideally insulated with external wall insulation. Essentially, that's placing an insulation board, which can be polystyrene, or it can be mineral wool, or in fact, it can be a wood fiber board as well. And so that fiber board is glued or mechanically, fixed onto the wall, and then a mesh and a render is applied to finish the wall surface to make it impermeable and let's say resistant to shock as well. There's a lot of advantages in external wall insulation. One, it's like a full wrap of the home. It deals very well with what we call thermal bridging, and I'll come back to you on that in a moment again. And it's you can add maybe 10 centimeters, 15 centimeters. In some cases, you can go as far as 20 centimeters, but 10 centimeters is already a fantastic achievement. And that doesn't take into the internal space, and there is minimal disruption, at least internally within the house. People don't have to move out when it's done. The downside of it is that it's quite expensive. It's a significant budget for an average house. And the other aspect is it needs to be done carefully. The detailing needs to be good. So there's no point pushing this lovely insulation layer and then having your concrete sills, for example, jutting out, or a canopy, you know, over an entrance door, and all these kind of sticky concrete elements would act as cold junctions and kind of weaken the insulation layer. So all these, let's say, key junctions need to be detailed properly, and a lot of attention to detail, in fact, needs to be given. And it's a specialist job. So it's important to work with people who are qualified and accredited by the Agremont board, that they're using the right materials for doing it. Internal wall insulation is the next option, which deals with the same issue. You know, it's a solid wall typically. It's hard to insulate, and you know, there's no cavity, obviously. So we're doing something quite similar effectively to external wall insulation, but we're placing a board of insulation inside, and then we're finishing it typically with a plasterboard. So the most common option is what you see in the middle picture here, with let's say a Kingspan board, if you want to put the name on it, and which is a pre-bonded plasterboard, and that plasterboard is skimmed over and to give you a lovely finish. You can also do it by placing sorry, words are escaping me right now. Timbers, vertical timbers, if I can call it that way, onto the wall, and then placing a mineral wool typically between those timbers, and then onto that you're fixing a plasterboard for your finish, right? And then the last option is to use a natural fiber material. Again, that can be fiber, let's say wood fiber, or sheep wool, or other similar materials. They can be fixed mechanically onto the wall, and then they can be rendered with a lime-based type of plaster, and that will give it the right finish. The advantage, let's say, with those type of natural materials, that they're generally more breathable, and allow the walls to breathe. So moisture can migrate out, in and out of the wall without condensing within the wall, which is important. So I think that covers internal wall insulation. So I guess let's say the downsides of internal wall insulation is that it takes space internally, and also it's very disruptive. Obviously, you know, you typically would have to move out of the rooms where it's been done, and sometimes move out of the house entirely for a period of time. And it's not as expensive external wall insulation, but it's still quite expensive compared to, let's say, standard cavity wall insulation. But in some cases, you have no choice. You know, like for maybe heritage buildings, for example, where changing the appearance of the facade is something that might not be acceptable. And internal wall insulation can really help in those situations. Or you can also do it room by room over a period of time, as opposed to external wall insulation, which typically should be done in the one go around the house. Windows and doors. Generally speaking, right, if you have single glazing, it's something to really consider, because you lose the heat loss through a window is many times what you'd have through a wall, even if that wall is not very well insulated. Same with poor quality double glazing. So if your windows are, let's say, 30 years old, PVC or aluminum windows, even worse, it's worth considering, especially as part of a deep retrofit project, and especially if you're looking at external wall insulation and even internal wall insulation. You know, these would be kind of the right times to upgrade your windows and doors. And if you do that, We'd recommend good quality double glazing with an insulation gas between the two panes, and reflective coating that will, let's say, trap the infrared radiation inside the home and reduce heat losses, making sure that they are airtight, that they close nicely and tightly, so that there is no drafts. But in some cases, you could consider upgrades your existing windows if they're in good condition, and if they're of a reasonable quality and insulation value. Well, then simply let's say refitting them, so making sure that they close properly, that the seals and the gaskets are all in good condition, or maybe repaired in some cases. That's a low cost measure, but that can really improve the performance of the windows and the doors without any major investment involved. There's another option, which could be to leave the window frame in place, right? And then replace the glazing with a high quality double glazing. There are now slimline double glazing which have a very good level of performance, and which can be placed as a replacement to existing bad quality double glazing or even single glazing, while retaining the existing frame. Sometimes the frames are not good quality timber frames. In period houses, for example, would be an important feature, in retaining them, as real conservation value. But generally speaking, if you can, especially as part of a deep pressure replacing doors and windows of highly insulated units, is great, not just from a heat loss perspective, but in terms of reducing noise and emission, especially if you live in an urban environment. Improving, let's say, the safety of the home is also a benefit of upgrading windows and doors. Floor insulation, typically one of the most difficult ones or insulation measure to implement. Solid walls, solid floors in particular, would require either to break them down, dig deeper, put an insulation layer, and let's say apply a concrete slab, which in most cases it isn't going to be done. Maybe for radical upgrade of the homes where it's a kind of strip everything back type of job, but generally speaking, unlikely to be an option. Suspended floors might be a more accessible option for floor insulation. So especially if there are structural issues that you might need to do repairs to the joists, you might want to replace the floorboards if they're totally worn, etc. And if that's the case, these would be good opportunities to upgrade the insulation in the floors. And the typical way of doing that is to put a mesh or a membrane between the joists. Let's say flow the insulation boards between the joists and supported by that membrane, and then apply over it another membrane that's going to prevent moisture to migrate within the insulation layer, and also act as a air tightness layer. And then seal that membrane around the walls, would do a super job. And even better, you could consider adding underfloor heating in those situations, which would be an ideal combination with an air source heat pump, but that's a different discussion. It's worth mentioning there's really interesting innovation happening even with insulation, and the picture in the middle here shows you a little robot that you can drop in the below the suspended floors that will go and inject a foam between the rafter, the joists from underneath. A lovely job. I haven't seen it done in Ireland, but there is a company in the UK that manufactures those, and I think they rent them. So it'd be great to see that as an innovation coming to Ireland. Thermal bridging. All right, so you're actually likely to be familiar with it. Unfortunately, all, let's say, masonry walls would typically have the cavity being kind of closed with a piece of concrete, which means that there's a direct connection between the outside layer, concrete layer, and the inside layer, and a cold spot. That cold spot is really prone to condensation, and that's what you see here on the picture at the top of the right top of the slide, where mold is growing. And that's a real problem from a health perspective, not just from a heat loss perspective. And so that's what we call the thermal bridge. They also occur anywhere, where there's a junction where the insulation layer is being bridged, if you want, and where the heat loss from the inside to the outside is intensified, and you're creating a cold spot. And again, that cold spot is not just a place where heat loss is being exacerbated, but also a place where you can have condensation and in worst case scenario, mold growth. So detailing for thermal bridging is important. That's why external wall insulation is so useful, is in that it can deal with many of those existing thermal bridges. As you can see here, the picture on the right side, that's where the insulation goes as far as maybe a couple of foot below the DPC level, so that you're effectively really mitigating that thermal bridge. Another aspect of dealing with the issue of condensation and mold growth is to ventilate the home properly and to extract moisture where it's being produced, typically in the kitchen, and in the bathrooms and utility rooms. So ventilating the home properly is also a great way to mitigate the risk of thermal bridge where it's not being dealt with insulation. So let's look a little bit at a case study. Here we have a bungalow that was built in the 70s, 2 or 3 bedrooms with cavity walls that haven't been filled, hardly insulation, any insulation in the attic, solid floors, double glazing that would be, quite old and in poor condition, an old oil boiler and poor controls, maybe just time clock if you're lucky, and generally quite drafty, uncomfortable, cold house. Fuel bills could be €2,300. Reality is that the house is rarely heated to the right level of comfort, and people are, generally have to put up with discomfort to save money. And CO2 emissions can be quite significant as well. So that's a prime case for a deep energy retrofit, and we're going to look at the different options from an insulation point of view. And it's worth mentioning we're starting with an E2. So the first step is to look at, what kind of shallow measures can we implement? And I've mentioned loft insulation as a low-hanging fruit, something that's relatively easy to do and not too expensive. Up to 300-400 millimeters of insulation. Pump the cavity walls and fill them entirely with polystyrene beads, the gray ones, which provide an additional layer, let's say, level of insulation. And that might cost you €1,800 for the size of house we're talking about. Basic draft proofing measures, so kind of sealing gaps and making sure that the windows and doors close properly, and the obvious holes in the fabric around waste pipes, electrical cables and that kind of stuff, and then replacing the old bulbs with LED lighting. So in total, we're spending maybe 4,200 euros, and we're saving about 850 euros per year. So the payback would be around 5 years of our grants, and there's about 2.5 tons of CO2 saved per year. Then we're looking at the deeper fabric measures, and sorry, I should have said that we're achieving a D1, sorry, of those shadow measures. Then we're going deeper, so we're adding to those shadow measures replacement of windows and doors with good quality so triple glazing, actually, in this case. We're insulating externally with a polystyrene board, and then we are doing a deep sealing. So, you know, we're paying a lot of attention to reducing air leakage wherever possible, and we're installing a mechanical ventilation system that's very efficient. So all in all, we're spending 33,000 euros, roughly speaking, and we're saving about 1,100 euro per year, and we have a payback of 30 years. That's without grants, so that would be reduced significantly with grants that, you know, typically would cover maybe 35% of the investment, and that is also reducing CO2 emissions by 4.5 tons. And we're getting to a C2. So we're getting close to our target of a B2. And the next measures after that is to look at the heating system. As I said earlier, you know, we've made the house efficient and good at retaining heat, and then we're looking to replace that. And that might be the subject of a future workshop looking at air source heat pumps, for example. It's worth mentioning that the energy costs we've applied to this case study are outdated at this stage, so the picture would look better from a payback period. So there are grants. As I mentioned last week, there's a number of options for homeowners to avail of grants from SEAI. For those that are a recipient of a form of social welfare, there's free energy upgrades available, fully funded by SEAI, where everything is managed by SEAI and its contractors on behalf of the homeowner, including a home survey, selection of contractors, management of the contract works, and then a follow-up BER is done. There is also the one-stop shop service where a homeowner can go to, let's say, a main contractor, let's say, augmented with a range of services in terms of advice, project management, help with grant applications, sometimes finance as well, and overseeing the works and quality controls that go with that, and then follow up on the paperwork and the BER assessment at the end. So it's really a hand-holding service provided by one-stop shops and supported by SEAI. And then finally, there's individual energy upgrade grants, which are useful for that kind of step-by-step approach in particular. And in that framework, we can apply for an individual measure. And in this next slide, I'm giving you an outline of the range of measures which are eligible for grants. So attic insulation, 400 euros, cavity wall insulation, 400 euros, internal wall insulation, let's say dry lining, ranging from 600 euros for apartments to 2,400 euros for a detached house, and then external wall insulation, again, with the level of grant ranging from 2,750 euros up to 6,000 euros for a detached house. As usual, I recommend the SEAI website for a range of information material and advice and guidance available there. Contact details for one-stop shops, you know, the go-to place to have information on home energy upgrades and insulation in particular. So good starting point is to use the website link here above. And this is my last slide, I think, and I'd like again to thank SEAI for the support to the Sustainability Community Network. I'd like to thank Ballyhura Development CLG for organizing the workshop, and also the Musqueam Local Development Company, who's also an SEC and sponsored some of the development of the material you're seeing tonight, and Reticus, which is, let's say, a side business of mine, which supports home energy upgrades, which has done some of the modeling work you've seen in the case study. And now it's time for question and answers. So I might have been rambling on, but we'll stop there, close the presentation, and very happy to take questions at this stage.
Thanks very much, Xavier. After presentations, I think it's common for people to say that was a lot to take in, but that really was a lot to take in. Thank you. I've been recording this. I might switch off the recording for the Q&A and I'll circulate it tomorrow to anybody who signed up for the webinar, whether they made it or not, because I think that's certainly one of the ones that we probably want to watch again.